Hi guys, welcome to all of you. So guys, kindly confirm once that whether am I audible to you or not, and then we'll start our session. And guys, tell me, how are you doing? How's everything going on? Is all good? And yes, guys, please mark your attendance as well. Okay, so guys, we were discussing about the atoms and the molecules. Okay, I hope so you have revised whatever we have discussed in the previous class. So if you have any doubt, you can please ask me. Okay, and meanwhile, let's have a recall test based on the topic that we have discussed in the last class. Okay, again 5 questions will be there, objective type, and you have to mark the answers in your notebook, and then we will check out the solution section, and let's see how many of you has got the all correct answers. And if you have got any doubt or confusion, you can please ask me. Okay, so guys, here we go with the questions. Please attempt these questions. Attempt all these questions, mark the answers. Once you have marked all the questions, just let me know so that we can proceed. Just confirm once, guys, once you have completed the questions. One more minute, guys, for this question, for these questions. On the next page, there is one more question over there. Done? Check out the next one. Solve this one. I think so we have discussed how to calculate the molecular masses. Okay guys, so let's check out the solution section. See, done guys. So guys, let's start with the today's topic, which is mole concept. Okay. So let's introduce the mole. What mole exactly is, and where can we use the mole? Okay. Guys, I hope so you have heard about the word dozen. Okay. Like for example, we can have 1 dozen of banana, we can have 1 dozen of apples, or we can say 1 dozen of any quantity. So what dozen actually signifies over there? What exactly dozen signifies over there? Yes, obviously 12. Means that if I say 1 dozen of banana, it means that I have 12 bananas. Okay. If I say score, score is also a word, score means 20. Okay. If I say 1 score of a particular substance, it means that I have 20 substances. If I say 1 score of an article, it means that I have 20 such articles over there. Okay. So actually the dozen, score, ton, kg, these are nothing but, these are not kg, these are nothing but we are using them just to simplifying our calculations, or we can say the large number of elements, or we can say substances we can group in a smaller fraction over there. Means if I say that 1000 dozen, it means that it is understood that I'll have the 12,000 articles over there. That's what the dozen signifies over there. Okay. So these are the quantities like dozen, ton, score. These are actually used in the daily life where we can see the object and where objects are quite limited over there. Means those substances are countable over there. Okay. But if I ask you about the water drop. Let's suppose this one. See. Let's suppose this is a water drop. Okay. Actually, guys, this water drop is not a single water drop. One second. This water drop is not a single water drop. It actually made up of small water droplets. I can say such type of water droplets. Many water droplets. Even this one is not single water drop. This is made of small water droplets like this. Even this one is not single. This one is made up of very small water droplets. If I talk about this particular water drop, even this one is not single. This one is made up of very small particles over there. Okay, so if I talk about in terms of the chemistry of, we can say, the microscopic level, microscopic means at the very small level, like in terms of the electrons, atoms, protons, neutrons, molecules. These are, guys, actually very smaller quantities. Okay, so yes, the very smaller quantities, but their number is very large. For example, if I say this is a very small piece of gold. So actually, guys, this piece of gold can contain millions of gold particles, and those atoms may look like this one. Oh, hi, Senapati. Okay, so this gold is actually, this gold sheet can contain, or we can say, this one can have huge number of smaller gold particles. Okay, now it is very difficult to deal with them. Okay, at that particular time over there. You think we are late, or you are late? I was on time, dear. Okay, I guess you have just joined. Okay, let's continue with this one. So we were discussing that it is very difficult to deal with such a big numbers over there. Okay, so to simplify that, like we use our dozen. Dozen means 12. Okay, that we can use in our daily life over there. Okay, but you can't use the word dozen in case of the particles over there, which are atoms, molecules, electrons, protons, or neutrons, because their number is very huge. Okay. So actually, what we did, we actually calculated, or we can say, we have assigned a particular value. If I say that number, it means that if I say the mole, see, mole is that number. If I say the 1 mole, it means that 1 mole will contain exactly those number of entities, about which we'll discuss later on. Okay, what exactly mole can have a number. Okay, or we can say one mole can contain how many particles or entities over there. Okay, so first of all, we have to understand that why are we using the mole. See, at the microscopic level, the number of particles are very, very large. So to deal with them, we need to assign a number which makes their calculations or to operate them quite easy for us. That's why we are using a word mole. Okay. Now, how we can calculate the mole? See. First of all, let's check out. Mole is the amount of substance that contains as many elementary identities as there are atoms in exactly 12 gram of C12 isotope. Okay, C12, guys, C12 means carbon 12. Okay, carbon 12. Here it is an isotope of the carbon, means carbon can exist in different forms like carbon 12, carbon 13, carbon 14, and out of these we are using the carbon 12. Okay. So mole is the amount of substance that contains as many particles, or we can say identities, as there are atoms in exactly 12 gram of C12 isotope. This is the definition of the mole. Okay, this is the definition of the mole. Now, if I ask you the value of the mole, so 1 mole has a fixed value which is equals to 6.022 into 10 to the power 23. guys, this 23 representing that after 6.022, I need to put 23 zeros. If I would like to simplify it, let's check out. See, or let's say suppose I write something like this. 4 into 10 to the power, 1 second. 4 into 10 to the power 3. Actually, this means that 4 into, or we can say not placing the into, can simply say, you can put the zeros here. 3 zeros over there. Okay. Or this one can also be written like this, 1000. Okay. If you say 5 into 10 to the power 5, it means that I can put 5 zeros after this. Now you are saying 6.022 into 10 to the power 23. It means that after 6.022, I need to put the 23 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. See, this is how big a mole is. Okay? This is how a mole big. Okay? So, guys, mole is not a small number. It is actually a very big number just to deal with the microscopic species over there. Okay? I hope so you have got the idea of the mole. And mole is actually this one. Okay? First of all, guys, tell me, just confirm me. Have you understand the meaning of mole? Means its definition and its value. Just confirm it to me. Then we'll proceed. Senapati, are you there? Okay, that's cool. And what about other centers? Guys, confirm once. Then we'll write its definition. You can copy this one, guys. Hi, welcome, Itanagar. Copy this one, guys, and confirm it to me. Copy and then confirm. Okay. So let's move on. Senapati, have you done that? Okay. Now the word molar mass. Ultimately, the mass of 1 mole of substance, is called the molar mass. Okay. Atomic mass or molecular mass in gram is equal to molar mass. Okay. Ultimately, let me tell you something. Look at this. If I ask you atomic mass of carbon, you will say it is 12 AMU. Okay, or U. If I asked you to convert this unit AMU into the grams, okay, the interesting part is, guys, the only unit will change and magnitude will exactly remain same. Okay, so if I calculate this mass in gram. Okay, in gram. Okay, so this is actually become the molar mass, and its unit will comes out to be 12 gram per mole. Actually, gram will always be introduced with the mole. Means that how many gram a mole of carbon-12 can contain. Okay, so you can check out one interesting thing over there, that here the magnitude was exactly same. See, magnitude is exactly 12 and this is 12, but unit is totally different. Okay, so this is how the molecular mass and molar mass are different. Okay, so you can check out that atomic mass of iron is 56, but molar mass is 56 grams. Okay, molecular mass of H2 is 18, whereas the molar mass of H2 is 18 gram. Okay, and guys, this is the formula of the number of moles that we have to learn. I'll discuss few questions based on this one. That number of moles is the given mass which is present in the question, which will be given in the question, divided by the molar mass. Okay. Then I'll discuss about the examples. Wait a minute. I'll discuss about the examples. Okay. You can just copy up to the number of moles section. Just copy and then confirm. Copy and then confirm. Guys, if you have any doubt, you can please ask me. If you have any question, you are most welcome. Just copy up to the number of moles section. Itanagar Senapati, guys, have you done that? Dear AMU stands for the atomic mass unit. Means it was calculated in the reference of the carbon-12. Means mass which is exactly equal to 1/12 of carbon-12 atom is AMU. AMU is mass exactly equal to 1/12 of mass of carbon-12 atom is atomic mass unit or AMU. Value of the mole is 6.022 into 10 to the power 23. See, this is written at the bottom, dear, that 1 mole is equals to 6.022 into 10 to the power 23. The magnitude will be same. For example, if you say mass of nitrogen, so atomic mass of nitrogen is 14 AMU, but molar mass of nitrogen is 14 gram per mole. This is the only difference. The units will get separated over there. Okay. So I hope so you have copied that. So let's check out something. See. Oh, hi. Good evening, Presidency College. It's nice to see you. See. The formula for the number of moles. 1 second. Formula for number of moles one second guys. Oh wow. Give me a minute guys. Yeah, back again. Number of moles is actually given mass upon molar mass. So guys, given mass would be present in the question. Okay. You can simply say this is N, this is W, and this is small m. Yeah, give me a minute, dear. I'll give you time to copy that. Okay. So just leave a page, 1 or 2 page of your notebook. Okay. And let's focus on the question. Okay. So guys, this is the number of moles, how we can calculate it. Now, let's check out a question. How many moles are present in 9 gram of H2O? Okay, guys, the molar mass of H2O is 18. Okay, 18 gram per mole. So just use the formula and try to answer this question. Try to answer the question. Got the answer, guys? Check out what mass is given to you in the question. I have given you the molar mass. Just solve that and you will get your answer. Yes, absolutely right, Itanagar. What's your answer, Presidency College and the Senapati? Yes, absolutely correct. So let's check out its answer. Very good, everyone. So given mass in the question was 9, molar mass was 18. So 9 by 18. On solving, we will get 1 by 2, and which is 0.5. Okay, 0.5 moles. Okay, I hope so it is clear to everyone. Guys, first of all, tell me, do you know how to calculate the molecular mass or the molar mass? If I say calculate molecular mass of H2SO4, can you calculate the molecular mass of H2SO4? Do you know the method? If yes, you can tell me the answer. Or if no, you don't know how to calculate it, then please let me know so that I'll explain it to you. Because in the next questions, I won't give you the molecular mass that you have to calculate by yourself. I can tell you the atomic masses, individual atomic masses. Hydrogen is 1, sulfur is 32, oxygen is 16. First of all, confirm it to me that do you know how to calculate? If no, you can please ask me. Very good, Itanagar. Who has got this answer? Can you please write your name as well? What about you, Presidency College and the Senapati? What should be the answer for this one? Very good. It's 98 AMU. Very good. So we can move on to the next question. This is the question for you guys. Calculate number of moles in 360 gram of glucose. Senapati, are you there? The formula for the glucose is C6H12O6. Okay. I can tell you the individual atomic masses. Carbon is 12, oxygen is 16, hydrogen is 1. Okay. Tell me, what can be answer for this one? If you want option, I can give you options as well. These are the options for you. 2 by 3, not 2 by 3, 1 by 3, 2, 3, 1 by 2. Check out and tell me the answer. Okay, very good. Okay, what's your answer, Senapati? Okay, yes, very good. See, number of moles we have to calculate. The given mass is 360 and the molar mass put comes out to be 180. So on dividing, you will get the 2 moles. So option B is absolutely right answer. Very good to all of those who has got the correct answer. I think everyone has got the correct answer. Yeah, Itanagar by mistaken, I guess so, or written the wrong part over there. Okay. Done? Next question. How many grams are present in 1.5 moles of CO2? Tell me the answer. What will be the answer for this one? Okay. Presidency College has got the answer. What about others? Senapati and Itanagar? What's your answer? By the way, absolutely right answer, Presidency College. Okay. Okay, let's check out. Just we need to use this formula, W by M. No, it's okay. Moles are given to 1.5 and molar mass, I guess so you have calculated 44. Molar mass should be 44. So when you multiply it, you will get 66. Sorry, 66 grams. Okay. Clear Itanagar? Any doubt? Okay, so guys, let's move on. Presidency College, please copy this one very quickly. Guys, by the time Presidency College copy this one, if you have any doubt or query, you can please ask me. Just copy and then confirm it. Itanagar Senapati, you can talk by the time. I mean, meanwhile, you can talk to me at that time. Or if you have any query or any questions, you can ask me. By the way, guys, when your exam going to start? Any dates decided yet? Your school examinations? Okay, 26th of November. And which chapters are coming in the chemistry section? Okay. Senapati, Itanagar, you don't have any examinations? Have you copied Presidency College? Okay, Senapati. Okay, March, so it's too far. No worry. Why would I worry? Copy this one up to number of moles only. Definition of molar mass and some examples. Have you completed your syllabus, Senapati? Okay, then it's good. What is coming in the chemistry section? I asked which chapters are coming in your examinations. No, mole will be again 6.02 to 10 to the power 23. It will always be 10 to the power 23. What which you are asking? Okay, so let's move on. Have you done that Presidency College? Okay, let's move on. Okay. Ultimately, this is they're telling us how we can calculate the number of atoms, molecules or the fundamental units. Okay. Let me explain it to you. In spite of copying this one, you can look at here. You can copy this one. See. Guys, first of all, look at this. If I say 1 dozen, can I say, I said 1 dozen element. Then can I say I have the 12 elements? Can I say that? Is it true? If I say 1 dozen element, it means that it has a 12 elements. Okay, that's fine. If I say 1 mole elements, then can I say it is 6.022 into 10 to the power 23 elements? Is it true? Is it true? Okay. If I say 1 mole electrons, can I say it is 6.022 to 10 to the power 23 electrons? That's it. That's what the flow chart was saying over there. Okay, let me draw the flow chart for you. See, you have to understand the meaning of this one. See, if I divide given mass with the molar mass, I'll get the moles. Okay. If I multiply these moles with the Avogadro number, see, 1 mole is represented by the Na, which is the Avogadro number. Okay. Then I'll get the molecules. There is some problem with the writing part, guys. So, molecules. Okay. If I would like to go to the reverse path, what will I do? I'll divide it with the Avogadro number. Here I have divided, so I'll do the multiplication over there. Okay. So first of all, copy this one, guys, and tell me, have you got clarification with this one? Are you clear with this one? Any doubt about it? Okay, copy and then confirm. Where you have got doubt, Itanagar, you can please ask your doubt. Or was it sarcasm? Wow. Now you can copy this. Good one. Copied. Okay. Copy and then confirm. Okay, guys, so let's move on. I think this one is already discussed with you guys. See, mass of substance multiplied by the molar mass will get the moles. Okay. Wait. Yeah, this is the question for you guys. Tell me. Fill up these blanks and then we'll check out the solution section. Once you have completed this, just let me know. Guys, are you there? Presidency College, Itanagar in the Senapati. Say hi once. Hi on the chat screen. Those who are still alive. Hi Itanagar. Only Itanagar is there. Okay, network issues. Oh, very good. Just answer these questions, dear. Is this the answer? Presidency College? Okay, just confirm it. Have you attempted all the part? Just confirm it to me. Then we will check out the solution section. Need not to type, just tell me, have you attempted that? Do not type anything. Just confirm, have you attempted or not? Okay, let's check. See, this is the solution part. Got it? Okay, cool. Next question. The question was saying the 1 mole of O2 molecules or hydrogen atom. What we have to do, just put the 6.022 at every blank. We'll get our answer. Number 2. Do this question. Question is 1 mole of H2CO3 will contain how many atoms? Check out the question, tell me the answer. This time I guess you can type the options. Whether it is A, B, C, D. How many days you will take, guys, to answer this question? I think you should be very quick to answer such questions if you have got the concept. Itanagar has given its answer. What about you, Presidency College and the Senapati Center? What are your views regarding the given question? Okay, let's check out. Yes, absolutely right answer. So congratulations to all of you guys. Just copy it. Okay, so let's move on to the next part. Next question for you guys. Check out the question. Tell me the answer. Tell me answer for this one. Quite mixed answers. What about you, Presidency College? What do you think so about this given question? Okay, let's check out the answer. It's false. Okay, let's check out. Question was, number of atoms in 1 mole of oxygen is equal to number of atoms in 1 mole of helium gas. Remember, helium is monoatomic gas, means only single atom of helium can exist, whereas oxygen exists as a O2. Okay, so they can't have the same number of atoms. Are you clear with my statement? I'm just saying that helium can exist as a single atom, while oxygen will always exist as a diatomic molecule, means as a O2. That's why they can't have the same number of atoms over there. Okay? Next question for you. If you have still a doubt in the previous question, guys, you can please ask me. If not, then you can please proceed with the next question. Okay. Okay, let's check out. Wow. You are saying C, but they are saying something else. Let me check the question. If the Avogadro constant is redefined as this one instead of this one, then which of the following would be change? Molar mass, atomic mass, number of atoms in 12 gram of C12 isotope. Guys, molar mass will change. Molar mass means that the mass defined for the 1 mole. If you remember, I have told you that if the mass of the carbon is 12 molar mass, it means this is a 12 gram per mole. Means that 12 gram contained in actually 1 mole. Okay. If you have changed the value of the mole, then obviously the molar mass will also get changed over there. Okay. Clear with this one? Are you clear with this one, guys? If not, I can take another example. Just confirm. Presidency College, Itanagar, Senapati, guys, is it clear to you? Whatever I have just told you. Need not to copy such a big solution over there. Just think about it. Okay. Next question. Check out the answer. Okay, we will see. Itanagar has given its answer. Presidency College and the Senapati are left. What do you think about this question, guys? Done. Guys, have you attempted that? Okay, let's check out. Option D. Option D is the correct answer. Confusion? See, question was saying a flask A contains 0.5 moles of the diatomic gas, 1 mole of triatomic gas of element Y. How many atoms of element Y are present in flask A? Yeah, sure. Oh yeah, just look at the question. They are saying the flask A contains 0.5 moles of the diatomic gas and 1 mole of the triatomic gas. Okay. Triatomic gas of element Y. How many atoms are present? How many atoms of element Y are present in the flask A? Yeah. Give me a minute. Flask A has 0.5 moles of diatomic gas and 1 mole of triatomic gas. How many atoms of element Y? No, it should be B. See. Look at this. They are saying the flask A has 0.5 moles of diatomic gas and 1 mole of triatomic gas. Okay, element is same, guys. 1 minute. Element is same. Yeah, got it. It contains 0.5 moles. One second, not it. It won't be the B. Okay, 0.5 moles of a gas which is diatomic. Okay, of element Y, and 1 mole of again Y, means element is same. The difference is this is diatomic. So if I talk about this one, diatomic means what? 0.2 into 2 plus. This is triatomic, means 1 into 3. If you solve this, 1 plus 3, it will comes out to be 4. So just multiply it with the Avogadro number. We will get our answer. This can be the answer for this one. Got it? Actually, the same element, the gas of the same element is present over there. Now is it clear to everyone? Confirm, guys. Because, okay, let me take another example. I hope so you understand the meaning of diatomic. Diatomic means 2 atoms. So you can say this is Y2. And triatomic means what? This is Y3. The moles given to is 0.5 and this one is what? 1. They are asking for the what? Total number of atoms. So what will you do? 0.5 into 2 plus 1 into 3. On solving, we'll get 1 plus 3 equals to what? 4. They are asking for the total atoms, na? Now got it? Okay. Just copy this one. Then we'll move on. Copy and then confirm. Okay, let's move on. Next question. Do it very carefully. Guys, ozone gas has formula O3. Ozone has formula O3. Oxygen has formula O2. Okay. Check out the question. Tell me the answer. What can be answer? Possible answer for the given question. Welcome, dear. Now tell me answer for this question. Okay, Presidency College has given the answer. Itanagar and Senapati. Guys, what do you think? What can be answer for this one? Okay. So, if you have got clarified with the last question, I guess so you should know the answer. Option B is the correct answer. Now, tell me, if you still confused that why option B is the correct answer, you can please ask me. And if you have got clarified, you can just let me know so that we can proceed with the next question. Okay. Check out. They are saying 0.5 moles of O2 and 0.4 moles of O3. Asking for the atoms, what will you do? 0.5 into 2 and 0.4 into 3. Okay, it will be 1. This one will be what? 1.2. So obviously O3 has contained what? How many? Oh, sorry, higher number of atoms over there. Now clear? Etanago, sorry. Now clear? Okay. Okay, so let's move on. You can copy even. You can copy this one just. Okay, let's move on to the next part. One second. Attempt this question and tell me the correct answer for this one. Which of the following students have the maximum number of atoms? They are given you the different states over there. Okay. Determine. See, Avogadro number would be common in every of these given questions. So what you have to exactly determine, just determine number of moles. See, just don't look at the question, means just don't go with the options only directly. Calculate moles in every case, then multiply it with the number of atoms in the molecules and with the Avogadro number to get the exact number of atoms. Okay, so Avogadro need not to multiply with the Avogadro number just to answer this such type of question. Okay, just take it as a constant over there, but rest value you can calculate. Are you getting what I'm trying to say? See, let me tell you something. Let's say suppose I have got 64 gram CO2. So how can I calculate the atoms? First of all, calculate the moles, which is 64 upon, take it O2 to make the calculation easier. 64 upon 32. This is moles. Multiply this one with the Avogadro number and with number of atoms in the molecule, which is 2. So if you solve that, you will get 4 into Avogadro number. In the second part, let's say suppose you are given 1 mole CO2. So how can you calculate the atoms? Moles into Avogadro number into 3, because in the CO2 there are 3 atoms. So this is what? 3 into Avogadro number. So now you can compare these two values. Obviously this value is bigger, so this one should contain the higher number of atoms. Okay. Remember guys, you have to always multiply with the Avogadro number to calculate the number of atoms. Okay. Just use this one to answer such question. Check out and tell me the correct answer. Okay. See what I was saying. Let's say suppose I have two scenarios. I have to compare the number of atoms of 64 gram of O2 with the 1 mole of CO2. I have to compare which one will have the higher atom. So what will I do? I'll first of all calculate the number of moles by the formula given mass upon molar mass. I'll multiply it with the Avogadro number. See, because O2 contains the 2 atoms, that's why I'll multiply it with the 2. Just solve this. Need not to multiply with the Avogadro number. Just place them as it is. So you will get what? 4 into Avogadro number. Check out the next question. See, 1 mole CO2. In the given question, moles are already present. So what I need to do, just multiply with the Avogadro number. Because CO2 has the 3 atoms. How? 1 atom of carbon, 2 atom of oxygen. That's why I'll multiply with the 3. On solving, I'll get what? 3 into Avogadro number. If I ask you that which one is bigger, 4 into Avogadro number or 3 into Avogadro number, you will simply say what? This one is bigger value, na? Okay, so this is how I can say that this one should have higher atoms. Got it now, Senapati? Just confirm. If still not, you can please ask me. I can take another example. Now guys, please tell me answer for the given question. Do this question, tell me the answer. Senapati, Itanagar, Presidency College. Okay. Okay. So let's check out. C would be the correct answer. Why? Because the number of moles in H2SO4 will comes out to be 2. If you solve that, 196 divided by 98 will be 2. Into number of atoms are 4 to 6, 7 in the H2SO4. So I think this one should have the highest value, 14 into Avogadro number. You want me to solve it? Guys, just confirm it to me. Just confirm it to me. You want me to solve it? Or you have got understand that? Okay, that's cool. Next question. Might be question of the day. I mean, last question might be. Just do that question, tell me the answer. I can tell you masses if you want. Calcium has mass 40, magnesium 24. You can note it down, guys. You can note it down. Calcium has mass 40, magnesium 24, carbon 12, sodium 23. Okay, they are given as well. Okay, Presidency College has given the answer. What do you think, Itanagar and Senapati? Okay, let's check out the answer. Why? Just calculate the number of moles. In both the cases, moles will comes out to be half. So half ratio half is equals to 1:1. Got it? Guys, have you got that? Okay, I'll explain it. See? In option C, I guess magnesium, the mass of magnesium was 12 gram. And carbon was 6 gram. Okay? So just calculate the moles. By using the formula given mass, which is 12, and molar mass is 24. This is 6 upon 12. Okay? So if you solve that, this one will comes out to be half, and this one is also what? Half. So if you solve that, half and half will get cancelled out, and they are actually can be represented like this, 1:1. Got it? Now clear? Or still you have got doubt? Don't feel shy, guys, to ask again. Okay, that's all. So guys, that's all about for today's session. Okay, the chapter is over. Remember guys, whenever we will have a test in the chemistry section, so test will be based on the current chapter that we have just covered now. Okay, so all the best for that test as well, and yes, you're free to ask your doubts. Even in the next class, if you have got any doubt from the current chapter that we have just discussed now, just covered now, you can please ask me. Okay, and yes, thank you so much guys. So I'll see you next time. Till then, take care. Bye bye. Take care of yourself. Stay healthy. See you next time. Good night.